Hello friends, and welcome to Useless Knowledge. Today, we're diving into the mysteries of the Sun. On August 12, 2018, in the early hours of the morning, NASA launched a spacecraft into space, the Parker Solar Probe, marking the official beginning of humanity's mission to touch the Sun. This probe is venturing deep into the Sun's atmosphere, reaching the scorching hot corona, where temperatures soar to 1 or 2 million degrees Celsius. Its goal: to study the corona and solar wind and transmit back precious solar data. But what is the Sun really? Is it just a giant ball of gas that's been burning for 4.7 billion years? Why is the corona millions of degrees hotter than the Sun's surface? What exactly is solar wind? Why does it speed up the farther it travels from the Sun? And how does it accelerate to supersonic speeds? The Parker Solar Probe aims to answer these burning questions, quite literally, by getting closer to the Sun than any spacecraft in history. Named after 92-year-old American astrophysicist Eugene Parker. This mission is the first time in NASA's history that a spacecraft has been named after someone still living. Why such an honor? Because Eugene Parker changed everything we thought we knew about the Sun. He discovered solar wind and, based on that discovery, posed a series of groundbreaking questions that turned our understanding on its head. NASA has placed high hopes on the Parker probe, hoping it will redefine our knowledge of the Sun, perhaps as soon as 2025. So, what exactly is NASA hinting at? To understand that, we have to go back to the first time Parker rewrote the story of the Sun. Back to 1956, the Cold War was heating up. After inheriting secret technologies from Nazi Germany, the US and the Soviet Union were locked in a fierce scientific arms race. At the time, a 29-year-old Parker was working under John Alexander Simpson at the Enrico Fermi Institute of the University of Chicago. Simpson, a key figure in the Manhattan Project, was already a towering presence in the scientific world and had begun focusing on heliophysics, the study of the Sun and its interactions with Earth. But not everyone agreed with the prevailing theories. Enter Ludwig Biermann, a German astronomer, who posed a sharp question: why do comet tails always point away from the Sun? Simpson, not expecting much, brushed it off as a coincidence. But Biermann had a theory. The Sun was emitting some kind of material that pushed on the comet tails, a notion that contradicted the belief that the Sun's atmosphere was static. Simpson thought it was nonsense and handed the problem to Parker, expecting him to debunk Biermann. But 5 weeks later, Parker stunned everyone, especially Simpson, by agreeing with Biermann. He declared that the Sun's atmosphere was not static, but dynamic and expanding. He named this phenomenon solar wind. Anyone familiar with academic politics can guess what happened next. Parker was ostracized. His mentor disowned him. His paper was rejected. But Parker didn't give up. With no funding, no lab, and no data, just pure logic and determination, he refined his theory. 2 years later, in a chance encounter, he cornered the editor of the Astrophysical Journal and begged for a chance to publish. The editor, skeptical but sympathetic, relented. "Parker, I think you're wrong, but I'll give you your shot." And so, in 1958, Parker's paper was published, but instead of fame, he faced fierce criticism, not just for his science, but for betraying his academic mentor. His reputation was in tatters. But then, space gave him a lifeline. In 1959, the Soviet spacecraft Luna 3 detected solar wind, a stream of charged particles traveling at 300 kilometers per second. By 1962, NASA's Mariner 2 confirmed it. Solar wind was real, continuous, and varied between 400 and 700 kilometers per second. The scientific community was shocked. Suddenly, Parker the Outcast was a visionary. His predictions, including the Parker spiral and the shape of the interstellar magnetic field, matched observations almost exactly. Some even joked he must have been on the phone with God. But the implications were profound. If the Sun were truly a giant fusion reactor, how could solar wind even exist, let alone be continuously accelerated. How could it form a kind of shell in space between the Sun and interstellar space? NASA's Parker probe is not just a mission to collect data. It's a mission to answer these deeper, unresolved questions and search for a new, complete theory of the Sun. Fast forward to today. The Parker Solar Probe has now been flying through space for 7 years, reaching speeds of up to 200 kilometers per second, the fastest human-made object in history. It's planned to complete 24 close passes around the Sun, each time edging closer to the corona, and ultimately diving into it. Now you might ask, how come Voyager 1 left the solar system in 35 years, but Parker needs 7 years just to reach the Sun? Well, escaping the Sun's gravity is like climbing 100 floors, hard but straightforward. Getting closer to the Sun is like descending just 2 floors, but in reverse. It requires you to slow down dramatically. Parker has to slingshot around Venus 7 times to reduce its velocity and spiral inward. That's why it takes so long. But how does the Parker probe survive such heat? Fortunately, space doesn't have an atmosphere like Earth, so temperature and heat don't behave the same way. Even though the corona is millions of degrees, the density is low, meaning there's not a lot of actual heat to absorb. Still, Parker's heat shield must withstand up to 400 degrees Celsius, so NASA developed a technological marvel, an 11.4 centimeters thick carbon composite shield that keeps the instruments behind it at a cozy 29 degrees Celsius. To handle the intense radiation, the shield is coated with a white, aluminum oxide base layer, then topped with a hair-thin tungsten film for durability. Nanomaterials were embedded to prevent cracking, even under intense stress. Behind the shield sit wide-angle cameras, detectors, radar, and antennas are all protected and all tasked with observing the corona and solar wind during this man-made, perpetual eclipse. On December 24, 2024, Parker made its closest pass yet. Just 6.1 million kilometers from the Sun's surface, the closest any spacecraft has ever been. Its final encounter is set for June 14, 2025, when it will dive within 6 million kilometers of the Sun, transmitting one last stream of data before its shield burns away, and it becomes one with the star it sought to understand. At its heart, Parker carries a special microchip etched with the names of over 1 million people, along with a photo of Eugene Parker and a copy of his 1958 solar wind paper. A 21st century tribute, almost sacrificial in nature, just like the ancients. So what is the Sun, really? In 2025, we may finally find out.